Hello everyone, this is Janaki, your online professor. So today in this video, let us try to solve the problem which is given here. Find the peak value, time period, find for this waveform which is given in the numerical, we have to find the peak value, time period, frequency, average value, and instantaneous value. Let us see how to find out these values. So you know that this is an alternating quantity. So the peak value of this alternating quantity is given like this. So since this is the current waveform, peak value is marked as Im. So the peak value, that is Im, is given as, it is given in the numerical itself, it is given as 20 amperes. Then the time period. Time period is also given T. Time period is the time taken by the alternating quantity to complete one cycle. So that is given as 1/100th of a second. That means it is 0.01 second. That is the time period for completing one cycle. The third one is frequency. Frequency is nothing but the number of cycles per second. So that can be related with the time period, and it can be given as f equal to 1 by t. So t is 1/100. So therefore f is nothing but it is 100, which is hertz. The unit of the frequency is in hertz. Then comes the average value. So the average value of any alternating quantity, that average value in the sense the alternating quantity, it is varying. It starts from 0, increases in the positive direction, goes to positive maximum, and then it reduces in the positive direction, goes to 0. Then again it increases in the negative direction and reaches back to 0. So it instantaneously, the magnitude of the alternating quantity keeps varying. But if we want to find out on an average for one cycle, the value of the alternating quantity, it is given by the formula. This is general formula for any alternating quantity, average value. Here the alternating quantity is current, so I average is given by the formula 2Im by pi. So Im is given here. So we substitute in that formula the value of Im 2 into 20 by pi, which will give us, if you have the calculator, you can calculate it. It is 40 divided by pi, which is given by 12.7 ampere. 12.7 ampere. So that is the average value of the current waveform, which is given in the numerical. And then the last one, which is instantaneous value. The instantaneous value of any alternating quantity is given by the formula Im, that is maximum value of that quantity, sine of omega t. So here omega is Im value is given. Omega is angular frequency, which can be calculated by 2 pi into f. F already we have calculated, that is 100 hertz. So it is 200 pi, and that is omega. 200 pi is 3.14. In that case 200 pi is 628. So that is the frequency, and the instantaneous value at a particular time is given at t equal to 3 milliseconds. So t we have to substitute as 3 millisecond. So it is 3 into 10 power minus 3. So substituting these values here in the formula, Im is 20 sine of 628 into 3 into 10 power minus 3, which will be given by 628 into 3. Let's find out. 628 into 3, which is given as 1984. That is, it is sine 1984. That is into 10 power minus 3 is 1.984. So 1.984 sine 1.984 20. So let us find out sine 1.984 in the calculator. So sine of this value into 20, that is given by the instantaneous value is 0.657 at 3 milliseconds. It is equal to 0.657 ampere at 3 milliseconds. That means I at 3 milliseconds is given by the formula 0.657 ampere. So this is the last value. So I hope you have got an idea how to solve the numerical. Yeah, thank you.